Okay, chapter 19, confidence intervals for proportions. So, statistical inference, using the data from the sample to make conclusions or inferences about the population. So, basically, we're using our small sample to create assumptions about the entire United States, for example.
Is it like the
or
the
like
tasting soup where you only need like a little tasty test?
sure, kinda.
Y'all know what I'm talking
Or
about.
like we, sample Minchville High School to get, all high school students in Virginia. Like, that's probably not the best because, obviously, but it's not exactly random. It's one school. But you get the point. We can sample one school to get the entire population for the state of Virginia or something like that. So our first step is to create a confidence interval. We gather the data from a sample. Hopefully our sample is a good one. We hope the sample proportion represents the population proportion, so we center our confidence interval at the same proportion. Because our sample isn't perfect, we create our interval with a margin of error. So a medical researcher estimates that the percentage of children exposed to lead-based paint, adding that he believes his estimate has a margin of error of about 3%. Explain what the margin of error means. So, what this means is he is confident, and it doesn't tell us how confident, so we're just going to say confident. He is confident that the true percentage of children exposed to lead-based paint is within 3% of his estimate. So plus or minus 3%. So if he thinks it's, say he's 67%, then from 64% to 70% is where he's confident that interval lies, is in there. Consider each situation described, identify the population in the sample, explain what P and P hat represent, and tell whether the methods of this chapter can be used to create a confidence interval. This is going to be like a throwback to chapter 2 with like writing everything out. A consumer group hoping to assess customer experiences with auto dealers surveys 167 people who recently bought new cars. 3% of the people expressed dissatisfaction with the salesperson. So what is the population as a whole? No.
167 people.
Nope. What did you say, Peyton?
People who bought new cars.
Yes, all people who recently bought new cars. What would my sample be? The 167 people surveyed. So your your sample should always be the smaller amount of people. Your population is as a whole what was being surveyed on a smaller scale. So P, this one is going to be the true percentage of all people who recently bought cars who are satisfied. So what do you think P hat might be?
The true percentage of the 167 people.
Yep, the percentage from the sample of the 167 who were satisfied with the experience buying cars. So we want to determine now, can we create a confidence interval? So we need to check our conditions. So is this independent?
Yes.
Okay, each person's experience is independent of the next. So independent. Is it random?
It doesn't say it is, but
Like
representative.
representative sample.
Yeah. It doesn't say, but we can make an assumption that it is, right?
Yeah.
10% condition. Is 167 people less than 10% of all people who recently bought a new car? Yep. Or even just people in general. So now we check success failure. So we're going to do N times P and N times Q. So N times, or 167 times, I guess they wanted them to be satisfied, right? So I guess that would be 0.97. And then the dissatisfied is the 0.03. What are those values? You're back.
Did you,
NQ
did you
is,
actually go?
5.01. Or just
I got to study for my president's quiz now.
When is that?
Tomorrow.
and the other one is like
At 1:35.
161.
Now, what do you notice?
That's less
Failure
than
not
10.
greater than 10.
Fail.
This is less than 10, so we do not meet this, so we could not create a confidence interval.
Well,
Oh. Finally, we had one.
well, that's crazy.
I don't know why that made me happy.
This is different.
Yeah.
Cause like we would just stop there.
But that's why it's essential, especially with confidence intervals, that we make sure that these things do work.
Yeah, we wouldn't have known.
Because, like, the problem is really. Yeah. There are a lot of reasons.
All right, so what percent of college students have cell phones? So this is the same thing we just did in the last problem.
Okay.
We're just doing a second one of them.
Nice.
So 2,883 students were asked as they entered a football stadium, and 243 said they had cell phones with them. This obviously was
Okay.
not in a recent year.
Yeah, I was about to say.
What do they have, pagers back then?
Or maybe they were
Oh my
lying.
goodness. They could have been
Or
lying.
they have 8-track tape. What is a pager?
Maybe they were at that college and they weren't allowed to have them.
True.
Yeah.
Yeah.
Only a few.
It's like this thing where you. I can't explain it.
All right, so what is the
Yeah.
population?
Population is
All
all
s-
college
All
students.
college.
All college students. What is our sample?
The students at the football stadium, entering the football stadium.
2,883.
2,883 students. We could say at the stadium if we wanted to be really specific.
I'm sure the people on the exam were like that.
So what is P for this one?
Like
Like,
all the college
percentage
students.
of like the students with the cell phones. Yeah.
The proportion of all students, and I'm just saying students generically, but college students obviously, with a cell phone. What would P hat be for this particular situation?
Percentage of
Students in
the sample of 2,883 that had cell phones.
Yep, the proportion of students at the game or at the stadium who had a cell phone. And at this point, we would probably want to go ahead and find what that percentage is just because it wasn't given to us. So I think in the last one, they told us 3% expressed dissatisfaction, but this one we don't have any kind of a number. So we would want to find that before we go down to do our confidence interval. So we would do 243 divided by the 2,883 and get that percentage, or I guess the decimal value, but. So that is the proportion of students that had a cell phone at the game, basically, is that number. So can we create a confidence interval? So we're going to check our conditions. So is it independent?
Yes.
How about random?
Doesn't say it's random, but I also don't think it's random
What
because
would be something that's
they're choosing to go to a stadium. Like,
Yeah. So it's kind of hard because we don't have enough information. This could go either way.
because it's random in the
So,
sense that you don't know
what
who is
extra-
walking in the stadium.
What extra information could make it not random? Like, what
Um,
added or taken away can make it not random?
Like, I'm trying to think of how to put it. So
Yeah.
what would definitely make it random is if they said, we did it at gate D
Okay.
and students could come in through 3 different gates. So this is the total number of students in the stadium. We surveyed this many out of that, because that would be more random because they would be going in different gates.
So like this one's kind of more like a census
Well,
sort of thing because it's asking. all
maybe,
the
maybe
students,
not.
so-
But I'm thinking legitimately, at Liberty, students going through one gate. So that means they could ask every single student that comes through, which is fine. But how many students are at the college? Was this random? Is this everyone went? Is this not everyone? So it's just,
Right.
they would need to more so just tell you that they randomly sampled people who came in kind of thing instead of. So it's hard to know. You can assume that it is probably. It seems random because everyone doesn't go to a football game typically.
So it's not going to be a perfect thing of every
Yeah.
college student.
If they said, all the students in the stats class at CNU, it's probably not random because it's specifically those kids that are in that class
Mhm.
kind of thing. So,
Okay.
yeah, usually it's going to be pretty obvious one way or the other one. This is just kind of a weird one. 10% is that less than 10% of all college students.
Yes.
And then success failure, we would have, I guess success is finding that they have a phone, so
I guess, yeah, that all works.
0.084 times 2,883 and I don't even know, I'm just going to write 1 minus 0.084 times 2,883. Really, as long as the smallest one is greater than 10, we know the other one will be. Bless you.
Okay, I got 242
No, we're not doing that again.
and 2,640.
You say 2,640.
Yeah, 2,640.
It's probably rounded.
Yeah, Josh rounded wrong.
I just didn't round.
Oh.
2,640.828.
I think it mattered too much because it's definitely higher.
Really?
Well, it kinda did, but it didn't add up to what you're supposed to have.
Okay,
Well,
well,
then
that's,
what am
it's
I?
higher than 10, Josh. isn't
All right,
it?
so
Yeah, we don't really do anything else.
let's just assume that it was random. Okay, can we create a confidence interval then? Yes.
C.
Apparently not, because Josh did round.
All right, confidence interval. So this is just going to be the formula for it. I'm going to write it out in words first, and then. So it's the statistic plus or minus the critical value times standard error. The critical value times standard error is margin of error. In terms of, I guess, symbols instead of words. Confidence interval is equal to p hat plus or minus z star times the square root of p hat q hat over n. All right, these next type of questions could be a concept type question you could see on the test potentially, okay? Because these are, even though they're in the examples, they are kind of more concept type questions. So, several factors are involved in the creation of confidence intervals. Among them are sample size, level of confidence, and margin of error. Which statements are true? And we're going to say why or why not, based on if it's true or false. For a given sample size, reducing the margin of error will mean lower confidence.
False.
I'm thinking if you lower the margin.
What happens if you lower your margin of error? What happens to your interval?
It gets
Becomes
Yeah.
Smaller, right? Because your margin of error goes from 4% to 3%. So that means your interval gets what?
small.
Smaller.
Yeah.
Which means what? We're assuming that we've captured the entire proportion, but if we shrink it,
So like we should have less confidence.
we would be less confident because it got smaller.
Right.
The bigger the confidence, the more that it would be inclined to be capturing our proportion of what we're looking for. So this is going to be true. The interval will be smaller. So we will be less confident that we capture the true proportion. For a certain level of confidence, you can get a smaller margin of error by selecting a bigger sample. You may want to think about this by plugging in a small, like a hypothetical smaller sample to your formula or a bigger sample and see what happens. True. Why?
Because like when you use like a bigger sample, your margin of error, it does in fact get smaller. When you use the formula there.
Okay. Does anyone agree or disagree? He says true.
It's saying you can get a smaller margin of error by selecting a bigger sample. Yes, I also agree.
All right. He is right.
If I
You are
plugged in
right.
500 and I plugged in 10.
True. A larger sample size means a smaller standard error, which thus makes a smaller margin of error overall. All right, for a fixed margin of error, smaller samples will mean a lower confidence.
What does it mean, fix the margin of error?
Like that it's staying the
Keep
same,
learning?
staying constant.
Oh.
Like it's 3% regardless kind of thing.
Oh, okay.
I'm gonna say false.
Why?
That's a good question.
And it can't just be because the first two have been true.
Because if you think about it, margin of error is fixed, so it doesn't change. So like that would I actually don't know the reasoning. I could be wrong.
Anyone else have an opinion?
I feel like if the margin of error is fixed, it's going to have like the same amount of confidence. But I don't know, is that what he was saying?
Why?
I don't know.
Just because if it's a fixed margin of error, so basically saying it's a fixed number, I guess, then I mean if you put in a smaller sample, it's going to be lower confidence. If you put in a larger sample, it's going to be larger confidence.
Yes. True. Smaller samples have more variability. So we will be less confident in capturing the true proportion. And yes, what you said does make sense, Josh. All right, last one. We'll stop here after this one. For a given confidence level, a sample 9 times as big will make the margin of error 1/3 as big.
would you go about like disproving things?
Making the sample 9 times as big
Oh, yeah, I guess it is.
mathematically.
Yeah, I guess it is true.
All right, so let's look. So the square root of p hat q hat over n. And if we make our sample size 9 times as big, I would have the square root of p hat q hat over 9n, which being multiplied, and I'm taking the square root means I could take it out to give me 1/3 p hat q hat over n, which is obviously part of margin of error. It's times z star, but that 1/3 there tells me that it would be true.
So they were all.
Or never know. All right, we'll probably finish this tomorrow, to be honest. If not, certainly by the beginning of Thursday we'll finish it. So.